We're going to make a complete leak rate and flow pack check on this airplane as we're cruising here at 16.5 VFR on our way to maintenance to let them know how we stand at this point. You notice I've dialed the cabin all the way down to sea level. Now because we're at 16.5, the cabin can't go much below 3,600 feet, but I'm asking for sea level to make sure I'm as much pressurized as I can be. If I now take my attention to the cabin altitude gauge, sure enough, it's slightly below 4, right about 3.6 at max differential pressure. And this airplane, by the way, max shows about 4.8. It's just a gauge error. I'm sure we're within the 5 plus or minus 0.1 tolerance area. So we're fully pressurized here. What I'm now going to do is turn the left bleed air switch off and watch what happens. Specifically, I want to record what the peak climb in the cabin is. Here we go. I'm going to call that a 1,700 feet per minute peak. Now while we're waiting for it to recover, what that tells me is a couple things. Number one, the left flow pack was definitely supplying air because I lost some airflow into the cabin. Some people think that if you turn off a flow pack there shouldn't be much change. No, that's opposite. If that flow pack is supplying half the air coming in, and for the cabin to be at a constant altitude, for every molecule of air coming in, there's a molecule going out someplace, either through leaks or through the outflow valve. So with that balance it up, if I now terminate half the input, there is a heck of an imbalance where the same going out momentarily, only half coming in. The cabin has to be losing air, losing pressure, climbing. That's why we saw the climb. But then the outflow valve responded and went to the closed position more, trying to bring us back to the initial condition, and it did. The cabin's still there at 3.8 or so. We're still max differential. So the second thing this tells me is the right side must be doing something pretty well to us on that. I'm now going to turn the left side on. Flow packs are designed to close rapidly, as you saw, in case there's smoke coming in, to get rid of that inflow of smoke from the engine, which is exceedingly rare. They're designed to open a bit slower. Sometimes you really have to be patient. It may take a couple of minutes before it finally decides to open up. In fact, I've seen some that won't open up until you bring power to idle and then reapply power. That seems to be the trick to sometimes get one to reopen. So I'm giving that time now to reopen, back in normal operation. Now we're going to try the other side. Right side off. And that, folks, is rare to see. Good old 90 Sierra, identical, same exact climb rate initially. So the right side was equally strong with the left, doing quite a bit. Beautiful. Now, what I'm next going to do is to turn the left side off. So now we have no air coming in, and we're going to see what the cabin climb is, and the peak it hits is our leak rate. Here we go. 2, 3, 35, 4, 47, maybe 4,800. Now, folks, the beach specification is that leak rate should not exceed 2,500 feet per minute. Well, when you have an airplane with a few thousand hours on it like this one, that is exceedingly rare to find that. It'd be wonderful if it was, and if we had a lot of money, a lot of time, could take out the interior and patch all the leaks of cables and shafts going through the pressure vessel. Wonderful. But what I think is important is basically two things. Can I maintain maximum differential pressure on one side alone? And you saw that we could. Number two, which I haven't demonstrated to you, but if I had to pull back power rather aggressively to keep the speed down during a turbulent descent, could I pull power back to my low magic number? For the King Air C90, it's 300 foot-pounds. Can I come back that far and still have enough air coming in? The cabin wouldn't start losing air, wouldn't start climbing. And if I can do those two things, maintain full pressure on one side alone, and come back aggressively in the power without the cabin climbing, I am quite happy. And even though the leak rate is well above what the beach specification calls for. Notice now the cabin is climbing slower. As the cabin comes closer to us, the differential gets less. Differential now about 2.4. There's less shove, pushing that air out the hole. I'm going to do this long enough to get the cabin high enough to check out the cabin altitude warning light. In these earlier models, it comes on at 10,000 feet, and there it is, boom, altitude warning, Yellow light came on right at 10,000 almost perfectly. So I made that check also. Saves the mechanics having to do that. When I turn on one flow pack, doesn't matter which one, I'll start the right, give it time to recover. There it is. Virtually impossible to avoid that big surge as that comes in. No matter what you have your rate set for, you're going to get a big surge. That's why I do one at a time. I'll do the other. Wait for its surge. And now we're back in business on the pressurization controller. The cabin's aiming for sea level. And let's demonstrate the rate control here. Rate's at minimum now, all the way counterclockwise. And at minimum, that cabin should barely descend at all. Probably 100 feet per minute down, if even that. Cabin's now going back down under 9,000 feet this time. Now let's take the rate knob all the way clockwise to maximum. And that usually makes the descent get with the program quite a bit. Almost always more than 1,500 feet a minute. Here you see it's about 2,700. Big range, that rate control. Let's try it straight up at the 12 o'clock position. I think Air Research, it makes that, says in theory that should give you about 500 feet a minute. Well, my experience is that each airplane is a little different. And also the position to get you a 500 feet a minute climb is typically not the same as what's required to get 500 feet a minute descent. So that's pretty close, by golly. I think I'll turn it more to the 11 o'clock position. And that brought us from 550 feet a minute to maybe 450 feet a minute. So we got some time now to have the cabin just slowly start coming down. We're heading over to Lake Havasu, which elevation is 783, about 800 feet. So I'm going to set that to 1,000 feet, a 200-foot cushion, and then I'm going to correct it for the altimeter setting. So let's now see what the old altimeter there is. 30.07. So that's almost 0.2 higher than normal. So I'm going to set this about 200 feet lower than normal, right back to field elevation. Now the book says use a 500-foot cushion and again correct it for the altimeter. Higher the pressure, set it lower. Each 1/10 of an inch, 100 feet correction. But folks, most King Airs, if you do conscientiously apply the correction, you don't need as much as a 500-foot cushion. So I've got a 200-foot cushion, even though it looks like I have 0 because of that higher altimeter. Well, we've checked out the leak rate, the float packs. Pretty darn nice airplane in my opinion. If it all do that well, I'd be very happy. Thanks for watching.